So let's look at number 13. We did one of these last time. So you have 3 different pieces, okay? And you've got to write 3 different functions. So what's it want us to write? We've got d of t. Do you remember doing the different graphs? Like week before last? You got this graph right here, right? What's his slope? 1 over 1. And what's his y-intercept? 1. Okay. What's the interval? Now he doesn't go forever. What's his interval? What's his x interval right here? What's that x value? The x value, 0. And what's the x value here? So this goes from 0 to 2. Do y'all remember doing this before? Okay. All right, then we've got another one. Does it help if I do them in different colors or no? Does that really matter? Doesn't matter? You might need to do different colors? You need it in different colors? I will do it in different colors for you, my dear. All right, here we go. Let's look at the next one. The next one is right here. Can y'all see that?
Do you have to underline it like that?
I'm going to underline it so you can see that we have 3 different pieces. Like, so you can see we need 3 pieces. No, you don't have to underline it. That's just a blank. All right, here we go. This is a straight line, right? So does a straight line have a slope? No, it's got a slope of 0, right? So where is it flatlined at? What's the y value? 3. So it doesn't have a slope, so we're just going to put 3. And then we got to figure out his interval. So what's the x value?
3 or 2.
2. And the x value that it ends at?
7.
So this goes between 2 and 7. Are y'all okay? All right, last one. Here we go. Last one. All right. So what's this guy's slope? 1, 2, 1, 2, 3. All right. Let's see if we can figure out where it hits the y. So let's do it again. 1, 2, 1, 2, 3. So 1, 2, 1, 2, 3 would be 5, right? 1, 2 would be 7. 1, 2, 3. Nope, it's not gonna work because I don't have enough room. So we gotta do it the hard way. All right. So we know the slope is -2 over 3, right? And if we didn't know where it hit the y-axis, we had to use those parentheses. Let's bring it back some memories from a while back ago. All right, if it's inside the parentheses, this is what we're going to go over today. If it's inside the parentheses, it moves which way? Left and right or up and down? Left and right. So how much to the right did it move? 7. So this would be opposite sign, so not a +7, -7. And then whatever's outside is how much it moved up and down. How much did it move up? 3. So that's a +3. And what interval is that between? 7 and 10. It doesn't have an arrow, so it doesn't keep going, right? So it'd be between 7 and 10. If it had an arrow, it would be 7 to infinity, right? All right, y'all okay with that one? All right, let's do one more. And that'll be finishing up from last week. So you've got, Kimmy thinks that the graph and the table below are representations of the same linear relation. Clara disagrees with her, or Carla. Carla disagrees with her. Who's correct? And explain your reason. All right, so we've got a first point of 0, -1. Is that point on that graph?
Yes.
Yes. All right, then we got 1, 1.
Yes.
That one on there? Yep. All right, then we got 2, 3.
Yes.
2, 1, 2, 3. Yep, there it is. And then we've got 3, 5. Do we know? Let's see.
Well,
1, 3, 1, 2, 3, 4. But that arrow tells us it keeps going, right?
Yeah.
Okay. So, is that table and that graph 2 good representations of the equation? Yes. So let's see. Look at what a question says. The question says who is correct? Kimmy is correct. Because you got to explain why you're right. Why are you right? How can we word that?
graph and a table are both.
How do we know the graph and the table are the same, though?
You solve the graph.
Ooh, what? Ooh, look at Piper going with a slope. Do you remember how to do the slopes here? So, change in y. What's the change in y here?
2.
Negative 2 over the change in x. So you got negative 2 over, let's see, negative 1 minus 1 is negative 2. 0 minus 1 would be negative 1. And what would that be?
2.
Positive 2. Let's look at this one. What's the change between these two? 2. And what's the change between these two? 1. That would be 2. What's the change between these two? 2. What's the change between these two? So that'd be 2, right? So Piper said Kimmy is correct because they have the same slope. What's another name for slope? There you go. They have the same slope or rate of change. And we have to completely defend our answer. What else do we know? What did we do? Because Piper was the smarty pants that came up with the slope. Very good job, Piper. Very good job. But what did we do? What else could we say? What did we do with those points? We graphed them, right? And so we could say, also, the points, right, Braden, on the paper? You getting it? The points on the table match with points on the graph. Graph. I hope we got that right, because I think it's 2 weeks, and we've got a math workshop test. About 2 weeks, and we got a math workshop test. Do y'all realize we only have 3 weeks left of the quarter? 3 weeks. That's it. We got this week, next week, and 1 more week. That's it. The first week in October. All right, so we finished math workshop from last week. You're going to get a new one tomorrow, and we'll kind of finish that stuff up. But here's what we're going to do. You need a graphing calculator for today, okay? So we're going to do our checkpoint from Friday, yeah? Which will be very, very, very quick and easy. We did not. All right, so we're on page 27, right? 27, here we go. You need a graphing calculator. If you don't have one, go get one from the table over there. You need a graphing one for today. And we're on this page 27. It looks like this. Thank you, man. Kenna. All right. Everybody got the graphing calculator? Ready, Jackson? Okay. All right, here we go. So, very first thing. You're going to look at those definitions, okay? Okay, you got another one? Okay. Comparison? Yeah. Okay, so the only definition that I want you to look at is the second one. So we're not really going to worry about the first one, okay? We're not really going to worry about the first one. All right, but the second one. The blank function is the simplest of the graphs in a family, okay? So think about your family, right? Think about the simplest form. And what kind of a function would that be? The parent functions. Ooh, do you remember all those parent functions that we did? Ooh, we did a whole bunch of them, right? We're about to go over a few of them right now. All right, so what's a constant function look like? It looks like a straight line, right? So let's put straight line. All right, so we call these something different. We didn't call them identity functions. What did we call them?
Linear.
We did call him parent, but what parent was this one? That's the linear. There you go. So we called it linear. And what's he look like?
Or,
What kind of straight line? He is a straight line, but huh? I just didn't hear you. What did you say?
Diagonal.
Diagonal. It's got it. What makes a diagonal? The slope. There you go. So this is a straight line with a slope. Because my slope is always in front of x, which is 1. All right, and the last one we're going to look at in here is absolute value. What's absolute value look like? What's the picture? It makes a V. There you go. V for value. Makes a V. Are y'all okay? Just for giggles, let's go over the other parent graphs we did. Just for giggles. Huh? Because it's fun. Math is fun. Alright, y equals x squared, okay? What did that graph look like?
That was a U.
It was a U. There you go. Let's see, what was the other one we did? We did, absolute value. We did square root. Yep. What did that one look like?
It was a half a U.
Half of it looked like a little ramp, right?
Yeah.
There you go. You need to know them because you got an ACT coming up October 28th. And I think I saw 3 of them on on the September one. There was one that if you knew what a parabola looked like, you could have picked the answer real quick. There was at least one like that. All right, last one. It was that one with the 1 over x. What did that one look like? It was real funky looking. Yep, there you go. It had the little piece right here and the little piece right here. Looked real funky. There was one of those on the ACT in September, which if you knew, I think it asked you something like, which one's the graph of a parabola or something like that. It was something crazy. And so as long as you knew that a parabola was x squared, you could pick the answer very easily.
When you say the September one, you talking about the green one there?
No, it was written in black above that one. I erased it because we're done. Yeah, it's the one last weekend. All right, here we go. So at the bottom down here, it says identify each type of function represented by each graph. Okay, so what kind of function is this one? Absolute value. Would help if you were getting it on the paper. All right, what's this one? That's a straight line, no slope. What's that one called? Constant. Yeah, because it does have a constant. That's why it's called constant. All right, and then what about this guy? He's called the identity, or what's another word we can call him? Identity / linear, right? Yeah, you just say ID, that's fine. As long as you know what that means, that's fine. Easy enough? Y'all okay? Everybody with me? Yeah? Wake up, I know you got the Monday blues. Alright, let's flip over. Page 28. Alright, so, we missed 2 days, okay? So, instead of us learning all these rules, we are going to learn all these rules, don't get me wrong. But we're going to do it a little different way with our calculator, okay? Because we've got 2 days we've got to catch up from. So let's look at this. We've already talked about this in Math Workshop. Where is that H at? Inside or outside? Inside. Just the H. This tells you where it's going to. And what does it tell you when it's inside? Where does it move?
Right and left.
Right and left. And you take the opposite sign, right? Y'all okay so far? With those two? Alright, Garrett, I'm going to do some different colors for you, okay? Alright. Okay. Maybe it'll help if we do this. If we kind of separate those like that. Does that help? That might help y'all to do the same thing. Okay? Alright, look at the K. Where's the K at? Outside. Alright, maybe we need to write that. We need to write inside. And this one we can write outside. Y'all okay? Alright. And so if we do outside, where does that tell us to go? Up and down. And we take the same sign. Okay? Now, when you get to pre-cal, you're going to learn about this guy. We're not going to learn about him right now, so you can mark that one out. When you get to pre-cal, you're going to learn about that guy. All right, the only one we're going to look at is where that negative is outside. What does that do when you have a negative outside? Flips it over which axis? The x-axis. So we have negative outside, flips graph over x-axis. Y'all okay so far? All right. Okay, and then these down here we're kind of just going to look at on our graph. All right, so let's look at the very bottom one down there. Number 1, you ready? All the way down there at the bottom. Try to move it up to there. Is that okay? All right, you got your graphing calculator? Ready to go? All right, turn it on. Turn your calculator on. All right, where do we go to graph something first? Do you remember? I know it's been a minute. It's been a couple of days. We go to y equals. You got to tell it what to graph first. So go to y equals. If you got anything in there, clear it out, okay? Now don't start yet. You know what? I'll pause for just a second. Hold on. All right, here we go. So, very first thing, I'm going to get you some of these calculators so you can highlight where we went, okay? So we need to do an absolute value. Absolute value, you need to hit the math button. Let me zoom this out so y'all can see. Alright, so hit your math button. You see it right below the green button? Alright, so hit that button. Okay, then we're going to go over to, we're going to hit the right arrow button, over to number. And what's the very first thing that's there when we get over to that button? Abs. Abs is the absolute value, right? Now, here's the thing. If you're, hit enter. If yours is not updated, yours will not show up with the actual absolute values. Yours will just say ABS and then a parenthesis. Does anybody have one like that so that I can show? All right, let me see it real quick.
Mine's 8 ABS.
8? Did you hit an 8 in? Oh, yours is updated. Yours is good.
What?
Yours is updated. There you go. All right, there we go. Matthew's got one. All right, so if you've got one of my calculators, see how it just says that? Y'all okay with that? It means the same thing. Yours is just not updated, so it just won't show up. It's never in. Okay. All right, so then here's what I need you to do. Very first thing we need to do is we need to type in the parent graph. So what does the parent graph of an absolute value look like? You need to flip back to your math workshop from last week, or week before last.
Y equals absolute value of x.
Y equals absolute value of x, right? Remember where the x was? It's right next to the green button. Don't hit any buttons besides the x. That's it. Some of us are ahead of me. We haven't done what we're supposed to do. That's Y equals. There you go. Math. You don't have to waste my time doing this. One number, hit x. Hit x. Close parentheses. All right. So then you can either hit the right arrow button or you close your parentheses. It depends on what kind you have. If you have one like Matthew, you're going to close your parentheses. If you have one like mine, you're just going to hit the right arrow button. Are y'all okay? All right. Then we need to go do it again. So we're going to hit the down button. Now let's type in the one that we have, okay? So let's go to math. Go over to number. Hit enter. All right, now you got to be careful about what we need to do, okay? The only thing that's inside that absolute value is what?
X.
X. So you're going to hit X. And if you've got a calculator like the yellow ones, you're going to close your parentheses. If you've got one like mine, you're going to hit the right arrow button. Because where is that plus 4 at? He's after, right? Then we're going to hit plus 4. But we should already be thinking, okay, plus 4. What is that plus 4 going to do to that parent graph? Where is it going to move it? It's going to move it up 4, right? Now let's hit graph. The blue one, the first one, is going to be your parent graph. The second one, in my case, the red one, is going to be the one that's the new one. That's the transformation. All right. So look at these vertex points. You see these vertex points right here? Where's the parent graph at? The origin, right? 0, 0. And where is the new one at? He went up 4, right? So what's the very first thing it tells us to do in the directions? Name the parent graph. So what's the parent graph of this one? Absolute value. There you go. So let's name that. And then what's it say to do?
Describe the transformation.
Describe the transformation, right? So what happened?
The graph shifted up 4.
There you go. So it moved up 4. Is that all it tells us to do? Okay, just so that we don't forget, let's talk about domain and range. What's the domain for this one? All real numbers. It goes all the way to the left and all the way to the right. What about range? What would range be?
0. Wait,
Starting from where?
sorry.
Bottom to top. Let's do the red one, okay? Where's the red one starting at? Positive 4, bracket or parentheses? Bracket, because it's closed. And then where's it going up to? Positive infinity. The only reason we're doing the parent graph is so that we can see how much it moved up and down and left and right. Okay, that's the only reason we draw this one. Does that make sense to everybody? All right, so let's go to the next one. We're going to go to the next page, I think. Yep. All right. Let's go to the next one. Here we go. Number 2. All right, so we got to go to y equals. We got to clear everything out. Okay, Jackson? Okay. So, what's the parent graph of this one? Which one? I can't hear you, guys. Linear or identity. And what's the parent graph look like?
Y equals X.
Y equals X. Perfect. All right, so go to your calculator. Let's clear everything out. Wake up, dear. You're not with us. We're on the 2. Live up to your potential. Come on. All right, so what's my parent graph? All right, so that's the very first one we're going to do. We're going to graph the parent graph. The only reason we're graphing the parent graph is so that we can see what?
The transformation.
How much is moving up and down or left and right, correct? All right, but we should already know that negative 5, x subtract 5, subtract, make sure you hit the subtract button, right, Jackson? Okay. We should already know that since that negative 5 is outside, what's it going to do to the graph? It's going to make it go down, right? So that's the parent graph. It goes right through the origin. And then that's your transformation. So now you can visually see what happened to the graph. So what happened to it? It went down 5. Perfect. Moved down 5. All right, let's go to the next one. Okay, what's the parent graph of this one? Absolute value. And what's the equation? There you go. All right, so let's go to y equals, and let's clear it out. All right, very first one. Do you remember how to get there? Where'd we go? Math, over to number, and the very first one was absolute value, right? Okay, so the only thing we're going to type in is the parent graph. What's the parent graph? Come on, guys, what's the parent graph? There you go. And then we're going to hit the right arrow button, or we're going to close our parentheses, right? Okay, then we're going to type in what they give us. So hit the down button. Let's do the second one. Go to math, over to number, hit enter, and where's the 3 at this time?
Inside.
He's inside. Inside, we already should know. Where's inside going to move? Which ways? Left and right, correct? But we take the opposite sign. So +3 is normally going to move which direction? Normally.
Right.
It would normally move right, but if we take the opposite sign, we should already know this is going to move which direction? Left. Let's see what happens. Ready? Very first one should be the parent graph. All right, what happened to it? It moved left 3, right? Y'all okay? All right, so we're going to say move left 3. Y'all okay so far? Y'all want to move to number 5 since it's already an absolute value? We'll just skip number 4 for just a second, so we don't have to type so much stuff in. All right, let's go to number 5. So what kind of graph is that? Absolute value. There you go. Yes, you have to write it because the direction said so. Parent graph is y equals absolute value of x, which we already have in our calculator. All right, now here's what's different on number 5. You ready? This guy right here, that tells you have to hit the negative way down here at the bottom, right there. You gotta hit that negative way down there. If you hit the subtract sign, it will give you an error, okay? Then we go to math, over to number, and hit absolute value. What's the only thing inside? X. So then you're either going to hit the right arrow, or you're going to close your parentheses, one of the two, and then what's it say after that? All right, now you have to hit the subtract 2 for that. If you don't hit the subtract 2, it will not give you the right answer, okay? All right, let's hit graph. The very first one is going to be our parent graph. The second one's going to be our transformation. All right, what happened?
Move down to and flip over to the x-axis.
Oh, perfect. I love your wording. Very good. It moved down 2, and it flipped over the x-axis. You can't just tell me it flipped. You have to tell me it flipped over the x-axis, okay? Y'all good with that one? All right. Let's do 6 and 7, and then we'll come back to 4, okay? All right, so let's go back to y equals. Don't mess with the first one. That's your parent graph. All right, how do we put in fractions? What do we have to do first? Parentheses. 1 divided by 5. Close parentheses. Then we go to math, go over to number, and hit enter. All right, what's the only thing inside?
X minus 1.
X, and then hit the subtract 1. What's outside? All right, so either close your parentheses or hit the right button, and then hit plus 3. Are y'all okay so far? All right, and let's hit graph. The very first one should be your parent graph. And we're graphing that one so that we can see what happened, okay? So look what happened. Ooh, that's funky looking. It's almost a straight line, right? Okay, so what happened to it? Let's talk first. It looks like the vertex is right about there. How much did it do? Right 1 and up 3. Beautiful. All right, what else happened to that guy? It's like, look, it was like this. It was this huge, big old V, right? And then what happened? He's like almost a straight line. So what happened to him? What do they call that? What kind of word can they call that?
Curve.
It is a dilation, that's right, but what happened? It got stretched, right? Which way did it get stretched? It was like this, and then it got stretched. Which way? Horizontally. Beautiful. So we got so here's what we need to say. It did get dilated, so it got dilated 1/5. What does that mean, though? Which is stretched, which way? Horizontally.
Do you have to write the stretch horizontally part?
Yes.
Like dilate?
Yes, you do. Because when you get to pre-cal, there are 4 different ways that it can be dilated. So you got to just know which one's which. Are y'all okay? Does that make some sense? All right, so let's do number 7. You ready? 7's an absolute value, so don't clear the first one. Ooh, are y'all still writing? I'm sorry. My printer is messing up, but I will have those little graphs to you tomorrow so y'all can highlight what parts of the calculator we went to, okay? I'm not really sure what it's doing. All right, here we go. So we're going to go to math, over to number, hit enter, and the only thing inside is 6x plus 2. And then we're either going to close our parentheses or we're going to hit the right arrow button. And you need to make sure you hit subtract. Subtract, okay? The only time you hit the negative button is if it's in the very, very front. Everything else is subtract. All right, let's hit graph. So we know that this was an absolute value. Okay, look at your vertex. Your vertex was here at the origin. Now it got moved way down here. So what happened? What did the 2 do to it? Oh, no, let's see. No. That moved down 4, right? And left 2. Down 4. And left 2. All right. So what happened? It was stretched like this, right? And then it went, ooh, and it got stretched like this, kind of like Gage was doing earlier when we told him to put his shirt down, right? So what happened? What happened to the graph? It got stretched vertically, right? Do you notice the difference between the numbers? Where's this number at versus where the other number is? Where was the 1/5 at? Outside, and it got stretched horizontally. Where's the number on this one? Inside, and it got stretched vertically. Or I guess you really could say compressed vertically. We'll just say stretched. So it dilated 1/6, or no, just 6, sorry. Which is stretched vertically. So let's bring back some memories. Y'all okay? From what we did about 30 minutes ago? Alright, last one. Let's go back to number 4, okay? What's the parent graph on number 4? Y equals x, which is the identity, or we can call that linear, okay? Alright, so let's go to y equals. Gotta clear everything out. The very first one you're going to type in is y equals x. The only reason we're doing that is so that we can see what happened, okay? We don't normally do it this way, but we missed 4 days, so we got to kind of catch up a little bit. So then we got 4x in the second one. And let's say graph. Alright, so the very first one is the parent graph, and let's see what happens to it, okay? Woo! Okay, what happened? Did it move up or down or left and right any? Oh, look at that y-intercept. It's still on the origin, right? What changed, Gabe? Slope. So when it's being multiplied, it doesn't move left, right, or up or down. What's that word you told us earlier? Dilated. Very good. So it dilated by 4. Alright, I gotta fix my paper scroll. Alright, so when it dilated by 4, what did that do to the graph? The red one is the new one. So what happened to it? Changed the slope, but did it stretch it horizontally? Or did it stretch it vertically? It stretched it what? Vertical. Very good. Vertical. Vertical, not horizontal. Vertical. Look at it. This is where it originally was. And it got pulled up. So it's vertical. Y'all okay with that? Alright, let's try to graph. Here we go. I'm going to teach you something new on your graphing calculator. Something new. Something else new. Alright, here we go. So what's it say to do? Yep. Does it say to, so what's the plus 3? The plus 3 is on the inside, right? So what does that tell us it's going to move? Where? Left, right, up, or down? Left, because you take the opposite sign, right? So take opposite sign. Let's put inside. Inside. Take opposite sign, okay? Inside. So that's going to tell me to move left 3. Right? So let's move left 3. 1, 2, 3, put a dot. Alright, now I know it's been about 2 weeks because we missed some math workshops and stuff because of the storms. But how did we do this? Remember if we had the parent graph, right? We're already at x is 0. What's the next number after 0? What's the next number after 0? 1, right? So if I go over 1, what's the x value? What's the absolute value of 1? 1. So I'm going to go up 1. Let's do negative 1. If I go over to the left 1, what's the absolute value of negative 1? So I'm going to go up 1. All right, start back at the origin. Not the origin, excuse me. Start back at your original dot. Let's do 2. If I plugged in 2, what's the absolute value of 2? I'm going to go over 2, up 2. Start back at your original dot. Let's plug in negative 2. What's the absolute value of negative 2? So we're going to go left 2 and up 2. Are you noticing a pattern? What's the pattern? Well, absolute value doesn't technically have a slope. What happened each time? How did we get each dot? We just went over 1, up 1. Over 1, up 1. So let's do it again. Over 1, up 1. Are y'all okay? Yep. No? So you're on a test and you're like, I don't know if I did that right or not. What could you do?
Graph it.
Alright, let's graph it. We got a map. And then we're going to type in x plus 3. And then let's say graph. Did you get the same thing? Y'all okay? Alright, let's keep going. What time we get out of here? 52? Alright. Alright, see if you can do 2, 3, and 4. 2, 3, and 4. What? I'll teach you later, because y'all not ready for that yet. I just realized that. Alright, y'all try 2, 3, and 4. If you see your partner and you want to get with your partner, try it with them, okay?
Checkpoint?
Yeah, we're going to do the checkpoint in just a minute. We're just going to do those 3 first. Those 3 shouldn't take you just a second. And the checkpoint is like one problem. It doesn't take long. All you gotta do is graph it. 2, 3, and 4. All we're doing is 2, 3, and 4. That's it. Yeah, looks nice. Looks nice. Hey, you need to do it without your calculator first. And then check it with your calculator because you're graphing, okay? the graphics. You can do it without your calculator first.
Wait, so you can't do your calculator first like that?
The only reason for otherwise I would be check this.
Oh, wait, no.
Okay, did y'all get that the first one moved it down 4? Okay, so we should be trying to do it without our calculators. And then we just go over 1, up 1, right? Y'all okay on that one? Yeah? Alright, what about number 3? What number 3 do? Flipped it over. Where's the vertex at though? It's still at the origin. There you go. But instead of going over 1, up 1 each time, what are we gonna do? Down 1. So over 1 and down 1 each time, right, Braden? Braden? Okay. It's a lot faster to do it without the calculator if you know the rule. Do not use the calculator. Don't rely on it, okay? You can use it to check your work, but don't rely on it. All right, last one, number 4. What's the 2 inside tell us? There you go. You're going to do opposites. Inside, you take the opposite. So we're going to go right 2. What about the 3? That's going to go up 3. So we're going to go right 2, up 3, and that's where our vertex is going to be, okay? And then what do we do each time? Over 1, up 1 on both sides, right? Y'all okay with that? Good on that? Alright, here's what we're going to do. We are going to get back in our seats real quick, and we're going to do a checkpoint. We've got about 3 minutes. Checkpoint should not take you very long, though. Does anybody want one of these calculators? These that y'all can highlight? Anybody want one? So you can highlight the buttons that we went to? Anybody else? Going once? Anybody else want a calculator so you can highlight the things? You can highlight the buttons that we went to. All right.